On September 5, 1977, NASA embarked on an audacious mission launching Voyager 1 into the boundless cosmos with a plan that lasted just 5 years. But guess what? More than 4 decades later, it's still out there journeying through new frontiers of space. However, in the spring of 2022, this legendary spacecraft sent some really mysterious data back to NASA, and it left even the space agency's top scientists puzzled. Recently, the spacecraft has sent even more strange signals that defied all explanations until now. Today, we'll unveil unprecedented insights into the data that have remained untold until now. Don't miss it. Voyager 1, a spacecraft launched 45 years ago, stands as a testament to the boundless fascination that enveloped the globe during the transformative decades of the 1960s and 70s. It was an era when the collective imagination was captivated by dreams of venturing beyond our earthly confines and exploring the mysteries of distant planets. These dreams were not mere fantasies, they were driving forces behind one of the most ambitious endeavors in human history, space exploration. During this pivotal period, the United States recognized the paramount importance of understanding and exploring our solar system. For this cause, the discussion of pioneering projects to send probes to neighboring planets took root in the late 1960s. In 1972, NASA's brilliant engineers unveiled a groundbreaking concept, a 3-axis stabilized spacecraft equipped with an orientation control system rooted in astronomical coordinates. This technological marvel, akin to a gyroscope, held the promise of enabling the spacecraft to meticulously maintain its direction as it ventured into the cosmic unknown. Its primary mission was nothing short of unlocking the secrets of our solar system, a mission that would take it on a journey of profound significance. Voyager 1's destination was set. It was destined for rendezvous with celestial giants like Jupiter and Saturn, its objective to unveil the mysteries of these distant realms and transmit invaluable images and data back to Earth, shedding light on the enigmatic and awe-inspiring phenomena that lay hidden in the depths of space. However, in recent times, Voyager 1 has embarked on an unexpected and perplexing chapter in its story. The signals it's begun transmitting back to Earth have left even the brightest minds at NASA puzzled, sparking intrigue and concerns among scientists and space enthusiasts alike. But to better understand this, let's first embark on a journey through some of the major discoveries made by Voyager 1 while fulfilling its mission. Voyager 1 and 2 are twin spacecraft launched from Cape Canaveral a few weeks apart in 1977. Contrary to their numerical order, Voyager 2 launched first on August 20, 1977. Voyager 1 followed a couple of weeks later on September 5, but because of a faster route, it exited the asteroid belt earlier than its twin, having overtaken Voyager 2 on December 15, 1977. Voyager 1 began its Jovian imaging mission in April 1978 when it was about 165 million miles from the planet. After a few months of travel, the spacecraft sent the first space photos of Earth and the Moon, which had never been seen from afar before. Beginning January 30, 1979, Voyager 1 took a picture every 96 seconds for a span of 100 hours to generate a color time-lapse movie to depict 10 rotations of Jupiter. Images sent back indicated that Jupiter's atmosphere was more turbulent than during the Pioneer flyby made in previous years. On February 10, 1979, the spacecraft crossed into the Jovian Moon system, and in early March, it discovered a thin ring circling Jupiter, less than 19 miles or 30 kilometers thick. On March 5, 1979, Voyager 1 had its closest encounter with Jupiter, approaching a distance of about 174,000 miles. During this journey, it also came into close contact with several of Jupiter's moons in the following sequence: Amalthea at a range of 261,000 miles, Io 13,500 miles, Europa 4,830 miles, Ganymede 71,280 miles, and Callisto 78,540 miles. Possibly the most stunning of Voyager 1's discoveries was that Io has extremely active volcanoes powered by heat generated by the stretching and relaxing the Moon endures every 42 hours as its elliptical orbit brings it closer to and then farther from Jupiter. This finding revolutionized scientists' concept of the moons of the outer planets. The spacecraft also discovered a thin ring around the planet, then making it the second planet known to have a ring, and 2 new moons, Theban and Metis. Following the Jupiter encounter, Voyager 1 completed an initial course correction on April 9, 1979, in preparation for its meeting with Saturn. Voyager 1's mission to Saturn marked a significant milestone in its exploration of the outer solar system. It surpassed its predecessor, Pioneer 11, by conducting a far-reaching investigation of Saturn, which included a comprehensive study of its rings, moons, and magnetic field. As the second spacecraft to adventure to Saturn, Voyager 1 aimed to achieve a deeper understanding of this gas giant and its intricate planetary system. During its mission at Saturn, Voyager 1 successfully met the majority of its scientific objectives. However, there were some setbacks, notably with the photopolarimeter experiments, which unfortunately failed to operate as intended. Nevertheless, the spacecraft made several groundbreaking discoveries during its encounter with Saturn, further enriching our knowledge of the planet and its celestial surroundings. One of Voyager 1's remarkable findings was the identification of 3 previously unknown moons, Prometheus and Pandora, often referred to as the shepherding moons due to their role in maintaining the integrity of Saturn's F-ring, and Atlas, which similarly played a shepherding role for the A-ring. These discoveries expanded our understanding of Saturn's complex moon system and the dynamics at play within its rings. Perhaps one of the most noteworthy revelations was the exploration of Saturn's largest moon, Titan. Voyager 1's instruments revealed that Titan possessed a thick atmosphere obscuring its surface from visible light cameras and telescopes. The composition of its atmosphere resembled Earth's, primarily composed of nitrogen, but it had a surface pressure approximately 1.6 times greater than that of our planet. This fascinating discovery raised intriguing questions about the conditions on Titan's surface and its potential for hosting unique environments. The spacecraft also captured stunning images of several other Saturnian moons, including Mimas, Enceladus, Tessis, Dione, and Rhea. These images unveiled the fine details of Saturn's intricate and captivating ring system, offering new insights into the planet's celestial dynamics. Additionally, Voyager 1 contributed to the discovery of Saturn's G-ring, expanding the catalogue of known rings around the gas giant. Voyager 1's journey continued after its mission at Saturn. Just as it harnessed Jupiter's gravity to propel itself towards Saturn, the spacecraft utilized a gravity assist at Saturn to modify its trajectory and increase its velocity. This maneuver set Voyager 1 on a course that would lead it out of the solar system, eventually reaching a staggering distance of about 4 billion miles from Earth. One of the most iconic moments in Voyager 1's mission occurred when it turned its cameras toward the inner solar system, capturing a poignant image that forever altered our perspective. Earth appeared as a minuscule pale blue dot suspended in the vast cosmic sea. This image, taken from a perspective that emphasized Earth's insignificance in the cosmos, carried a profound message for humanity, a reminder of our planet's fragility and vulnerability in the grandeur of the universe. As this momentous occasion unfolded, the cameras on Voyager 1 were deliberately powered down, marking a transition for the spacecraft. It had completed its close encounters with planets and celestial bodies, and its trajectory would no longer lead it near any objects for further exploration. Nonetheless, Voyager 1's remarkable journey was far from over as it continued to transmit data while venturing deeper into the uncharted realms of interstellar space. In 1998, Voyager 1 achieved a historic milestone by surpassing the distance traveled by Pioneer 10, becoming the farthest artificial object from Earth and embarking on an unparalleled odyssey through the cosmos. In the annals of space exploration, 2004 marked an extraordinary milestone as Voyager 1 etched its name into the annals of history. It became the first spacecraft to transcend the boundaries of the heliosphere and venture into the cosmic expanse known as interstellar space. This epic journey was not without its tribulations as Voyager 1 navigated through the termination shock, a region where particles moved at speeds slower than sound itself. Within this tumultuous realm, the solar wind, a maelstrom of charged particles in the form of plasma, underwent a remarkable transformation. The outcome was a surge in both temperature and pressure, a testament to the dynamic forces at play within this celestial crucible. Interstellar space, in stark contrast, presented a vastly different cosmic landscape. Here, the density and temperature were markedly diminished, but it was not devoid of its own unique pressures. As Voyager 1 encountered these novel conditions, the heliosphere, that protective bubble of solar influence, underwent a dramatic metamorphosis. It compressed, twisted, and exerted force upon the particles it encountered, marking the spacecraft's transition into the unknown realms of heliopause. The voyage across the heliopause and the culmination of this momentous odyssey were not without their share of challenges. Voyager 1 bore the brunt of significant overloads and a shockwave as it pushed past the heliosphere boundaries. To add to the complexities, the ground-based antennas responsible for receiving Voyager 1's invaluable data fell silent during this critical phase of the mission, leaving the spacecraft to journey onward into interstellar space with its signals unheeded by Earth. 8 years later, in the transformative year of 2012, Voyager 1 charted a course across the heliopause, traversing the boundary where the realms of solar material merged with the vast expanses of particles from distant stars. This historic feat marked the first instance of a human-made object venturing into the heart of interstellar space, a testament to human ingenuity and ambition. In the following year, 2013, Voyager 1 recorded an extraordinary acoustic phenomenon within the cosmic void. A solar kernel mass ejection sent forth a wave that reverberated through the spacecraft's surroundings, which now held a density diverging significantly from the heliospheric norm. This density was nearly 40 times greater than prior measurements, and the distinctive high-pitched tone of the signal constituted the definitive confirmation of Voyager 1's unprecedented foray into this novel cosmic domain. As Voyager 1 embarked on subsequent years of its interstellar sojourn, it encountered a series of solar tsunamis, each a fountainhead of invaluable data transmitted back to Earth. These occurrences not only facilitated the development of advanced models of the solar wind but also afforded scientists the opportunity to probe the intricate interplay between the heliosphere and the interstellar medium. In 2017, the mission team orchestrated an audacious feat, reigniting Voyager 1's backup engines after a hiatus spanning an astonishing 37 years. This remarkable testament to engineering resilience ensured the spacecraft's continued journey into the cosmic unknown, unhampered by the passage of time. Fast forward to 2021, and Voyager 1 found itself amidst what NASA aptly dubbed clean interstellar waters. Here, it embarked on an unprecedented endeavor, engaging in continuous measurements of material density within the interstellar expanse. The mission team discerned fluctuations in the environment by closely monitoring the frequency of signals emanating from the probe. Higher electron densities correlated with elevated sound frequencies, while lower densities conversely produced a mellower tone. Interestingly, the team documented sporadic dips in signal tone, at times resembling readings akin to Earth's atmospheric conditions. However, as the calendar transitioned into early 2022, the storied veteran of space exploration encountered a perplexing enigma. It began transmitting distorted telemetry data, a mystifying conundrum that confounded the team of engineers entrusted with its care. The Voyager 1 probe and its intricate systems were seemingly operating like clockwork, obediently following the commands received from Earth, performing its tasks dutifully, gathering valuable scientific data, and then transmitting these findings back to its home planet. However, beneath the veneer of normalcy lay a perplexing anomaly that threatened the integrity of this iconic space traveler. The Attitude Control and Articulation System (AACS), responsible for maintaining Voyager 1's orientation towards Earth and ensuring seamless communication, began to exhibit erratic behavior. It provided signals that were far from reliable, rendering the spacecraft's position data seemingly randomized. This predicament was no trivial matter. A failure of the AACS could potentially spell the loss of the spacecraft itself. The AACS continued to function, delivering a reasonably strong signal, yet it was mired in the enigma of erratic positioning data that defied conventional explanation. As this puzzling situation unfolded, the seasoned team of engineers and scientists at NASA found themselves in a complex conundrum. Adding to the complexity of the situation was the fact that Voyager 1 did not initiate a safe mode, a scenario in which a spacecraft typically defaults to performing only its most basic functions while granting access to diagnosing equipment and software. Consequently, the engineers had to endure a nerve-wracking wait of more than 20 hours before they could commence the data exchange needed to resolve the issue. Navigating this cosmic riddle was further complicated by the spacecraft's aging components. While NASA's press service refrained from specifying the duration of the Voyager 1's enigmatic location problem, they did reassure the world that their dedicated team of engineers was prepared to adapt to these novel working conditions. Suzanne Dodd, the project manager for both Voyager 1 and Voyager 2 at NASA's Jet Propulsion Laboratory in Southern California, emphasized that such mysteries were not entirely unexpected at this stage of the mission. After all, both spacecraft had exceeded their expected lifespans, having thrived in an environment brimming with radiation challenges as they journeyed through interstellar space. In a remarkable twist, the lost space traveler was finally retrieved and restored to its trajectory in August 2022. The culprit behind the enigmatic telemetry data was identified. An onboard computer that had malfunctioned many years prior had unexpectedly sprung back to life, attaching itself to the data transmission chain. This long-dormant computer, previously disregarded by the team, emerged as the source of the erratic coordinates. When suspicions arose that this dormant computer was at the heart of the issue, a decision was made, albeit with low-risk considerations, to instruct the AACS team to redirect data to the functioning computer. This action successfully resurrected the transmission of telemetry, and Voyager 1 resumed its place in NASA's spacecraft movement plan. Despite having cracked the enigma, NASA engineers remained puzzled by one lingering question: why had the AACS initiated routing data through the non-functioning computer? The prevailing theory was that the AACS had potentially received an erroneous command from another onboard computer, suggesting the presence of a malfunction elsewhere on the spacecraft. While the team continued their search for this elusive root cause, they were confident that the situation did not pose a long-term threat to the health of Voyager 1. Suzanne Dodd expressed optimism, stating, "We will do a full AACS memory read and look at everything in depth. This will help us diagnose the problem that caused the telemetry errors and conduct further investigations." As of today, Voyager 1 continues its awe-inspiring journey, sending back fresh insights about the mysteries of interstellar space. NASA anticipates that the spacecraft's engines will remain operational at least until 2025. Each year sees a decline of about 4 watts in electrical power production, imposing limits on the number of systems the generator can sustain. To mitigate this challenge, mission engineers have judiciously deactivated heaters, prioritizing the noble quest for space exploration. Notably, no scientific instruments have been sacrificed due to reduced power, and the probe steadfastly collects data with its cosmic ray instrument, plasma instrument, magnetometer, and low-energy charged particle instrument. The Voyager team tirelessly endeavors to prolong the collection of unique scientific data, ensuring that Voyager 1 continues to journey across the cosmic expanse, covering many more miles before it eventually goes into its celestial slumber.